Morning students, welcome back to digital signal processing class. In the previous class we have discussed some topics related to butterfly diagrams, that is DIT, FFT, decimation in time, fast Fourier transform, and decimation in frequency, fast Fourier transform. In that we have seen the summary of radix to DIT, FFT. In today's class we are going to continue, that is DIF, FFT. In that we are going to see the topic, how do we take the steps for radix to DIF. What is DIF stands for? Decimation in frequency, fast Fourier transform. That we are going to see in today's class. And we are going to see some numericals based upon these concept DIF, FFT. So basically what is DIF, FFT is all about? So first thing we should know what is the steps in order to proceed with these concepts. So in that, what is the first input, number of input combination? Capital N is equals to 2 power M. So number of combination, if you do have 2 stages, then the combination should be 2 power 2, that is 4. From 0 to 3 bits we will consider. Like if you had 3 stages, then how we take 2 power 3, that means it's 8. 8 would be 0 to 7. Those number of bits we have to take. That depends upon given number of points, 8 point DIF FFT or 4 point DIF FFT or 2 point DIF FFT. Depend upon the number of points, we are going to find the particular function for it. That is number of input samples, where capital N indicates what? Samples. This capital M indicates what? It's nothing but number of stages. So how do we take, how many number of stages is required in order to solve the problem related to DIF FFT? Next step, as we have discussed in the previous class, there are 2 types of inputs we are considering. One would be the normal order inputs, second would be the bit reverse order input. So in normal order input, what we have seen in DIT FFT, input needs to be in bit reverse order and output is in normal order. When we design the butterfly diagram for DIT FFT, the input values, whatever we are taking, what is our input value we have taken? We have taken 0. Then after that 4, then 2, 6, 1, 5, 3, 7. And what we have said, each difference of the bits needs to be 4. As you can see here, in all the adjacent bits, we can see these are called what actually? These are called bit reverse order. So this is therefore DIT, decimation in time, fast Fourier transform. Whereas in this decimation in frequency, fast Fourier transform, this is in output stage, not in the input stage. Input needs to be in normal order. Normal order means 0, 1, 2, 3, 4, 5, 6 and 7. So these are called what actually? These are called as normal order. So that's the reason we are saying number of input sequence of the samples should be in normal order. Clear? Next thing, to draw the flow graph, to draw the particular graph diagram, that is nothing but the butterfly of it, we need to take the formula to get this thing. So M is equals to log 2 of N. N is indicates number of samples. So what is M indicates over there? Number of stages. So if you want to convert that stages, like I want to apply log on both sides, I'll shift this, it will become log 2 of N. M would be as this. So I got this, M is equals to log 2 of N. Similarly, each stage consists of how many number of butterflies? So each stage consists of N by 2 butterflies. That means if you take one stage and another stage, if I am having, suppose this is Pn, this is Qn, I want to write the output of it. For writing this, what I'll write? I'll write the weighting sequence Wn of Nk, and for the feedback I'll mention -1. This is what 2 stage. In that I am taking 2 butterflies. Like that, depends upon the number of butterflies what I can take. I can take more than 2. That depends upon our stage N by 2. Clear? So likewise, next thing, to write input and output for each butterfly, which are separated by this one, 2 power capital M minus small m, where M represents stages index, means M is equals to 0, 0th stage, M is equals to 1, first stage, second stage, third stage. Like that, we'll start from first, second, third. Like this, we'll take the all stages of your DIF FFT. Likewise, we know this thing, complex multiplication is what? N by 2 log 2 of N. Complex addition is what? N log 2 of N. This is exactly similar to decimation in time FFT. Decimation in frequency and decimation in time have this common factor in both. Similarly, twiddle factor. So twiddle factor, what we actually, twiddle factor is nothing but the exponent factor, e power minus j 2 pi k n by capital N. N is nothing but number of samples, k and n, small n, that is nothing but the variable in which we are converting the digits and the variables. Likewise, here if you want to write that particular thing, I can write in terms of 2 power. So what I am writing, k is equals to capital N small t. This is a t domain. 2 power m minus small m plus 1. What is this capital M? M indicates what? Flow graph. And what is a small m? Small m indicates what? Stage index. And then k value we can find by using this DIF FFT. Likewise, we'll do some problems for 4 point. DIT will start first. DIT FFT will do 4 points, 8 points. Then we'll go for these DIF FFT. So basically, what is the conclusion of this topic? This is the graph which is quite easy to solve the problems related to your fast Fourier transform, because it depends upon Fourier factor, that is Fourier transform. So we can do that one by using discrete Fourier transform, where we need to apply the formula, where we need to substitute all the kind of values. So that same thing we can get the answer by using the graph. So in that graph, what is the two things we have discussed? First thing we have discussed, decimation in time, fast Fourier transform. Second is decimation in frequency, fast Fourier transform. So let us see some problem based on this. Let's take a problem, students. So in that they gave one question. We are doing the problem. First question is compute 4 point. They gave a question, compute 4 point DFT of the sequence. So compute 4 point DFT of the sequence. So students, so they give question, compute 4 point DFT of the sequence x of n is equals to 0, 1, 2, 3 using DIT algorithm and DIF algorithm. What is DIT stands for? Decimation in time algorithm, that is decimation in time fast Fourier transform, and decimation in frequency fast Fourier transform. So we have to solve these kind of questions. So they gave the question here, DIT algorithm and DIF algorithm. So first we'll proceed the first problem based on DIT algorithm. So we'll take first concept, DIT algorithm. So in this basically how many points they ask? They ask 4 points. So when they ask the 4 points, what is the two things you need to keep in your mind? What is a normal order and what is a bit reversed order? For that what I am doing, I am taking x of n is equals to, this is what? 0, 1, 2, 3. This is position x of 0, x of 1, x of 2 and x of 3. First thing I need to write bit reverse order. So for that what I am writing, for bit reverse order, I'll write down the normal bits. So what is the normal bit they gave? 0, 1, 2, 3. So I'll take the combination of it. So this is what? Normal order. So I'll take combination. So what is the 0, 0 combination is what actually? It's 0, 0, like 0, 1, 1, 0, 1, 1. I need to write that index into what form? Reverse form. That means digits should be reversed. So this should be reversed, it will be 0, 0. So 0 will be 0 only. 0, 1, change the bits. So 1 in place of 1, you replace with the 0, 0, you replace with 1. So I can write it as 1, 0. So 1, 0 now it will make it as 0, 1. 1, 1 make it as still 1, 1 only. So what I get? This is 2, this is 1 and this is 3. So this which order it is? Bit reverse order index. So we have to take this. When we are writing in DIT FFT, this is your input bits and this is your output bit. Because when we have discussed radix to DIT FFT, we have states that input should be in bit reverse order and the output is in normal order. So first we'll write that particular thing. So first I'll try to draw the graph for it. What I'm doing, I'm taking 4 points, 1, 2, 3 and 4. What is the first input? I'm writing the input value for it. So what is the first input I had? X of 0, then X of 2, then X of 1, then X of 3. So what is X of 0? It's again 0. X of 2, it is what? It's 2. X of 1, it's what? 1. X of 3, it is 3. It's not necessary that they'll give 0, 1, 2, 3. They can give any number. So but the position needs to be understood. How do you proceed with that particular question? So what is the thing we need to draw? We need to write the stage 1. In stage 1 what I am doing? I am taking the 4 point location like this. Next thing, I'll combine this with the next one, this with the first one, and this is what? This is what? Minus 1. It's a feedback. W, what is this? 4 point, right? W4 of 0. So we got this first. Likewise, I can combine, and for the feedback what I need to write? I need to mention it is minus 1, W8 of 0. This is what we have taken. 1, 2, 3, 4 points, and we have taken what actually we designed for stage 1. Stage 1, 2, 2 you need to cross it. For the second one, what is the second thing? We need to go for stage 2. For the second stage, stage 2, or you can write it as its output, right? So how many points? 1, 2, 3 and 4. So this fourth one we will combine like this. This one will combine. Clear? So likewise we will combine with the first, we will combine with the second. So here 2, 2 you need to combine. So what is this Twiddle factor and weighting sequence, where it will come? It will come in feedback. So W4 of 0, W4 of 1. Because we have 2 stages, right? So we have mentioned first and second stage. For the feedback what we need to write? We need to write its respective value. So what is the feedback value here? This is a feedback, right? From here to here. What is that feedback value I can write? I can mention it is, what is this value? It is nothing but minus 1. Feedback value, what is it is? It's minus 1. So what is the output stage? This is your output, right? Output should be in which order? X of 0, X of 1, X of 2 and X of 3. So we wrote that particular output. So what is actually the conclusion of this first one? We have only designed, we did not realize. So first thing is that we need to realize also. So what type of it is? Nothing but 4 point. What is which algorithm we are taking? DIT FFT or DIT algorithm. Now we need to find for every stage what are the values. Like this is stage 1. What is this input value here? What is this value here? What is this value here? And what is the value here? That value we need to find out. How do we find? We need to know what is weighting function W4 of 0, W4 of 1. That value I'll find out. What is Wn of k? Wn of k is nothing but e power minus j 2 pi kn by n, right? So here we do have W4 of 0, e power minus j 2 pi by 4 of 0. So nothing but 1, because e power 0 will be 1. Likewise I'll find second value. What is second value? W4 of 1, that is nothing but e power minus j 2 pi by 4. In place of kn we should write 1. So 2 1s are 2 2s are. So we got e power minus j pi by 2. So what is this e power minus j theta? Cos theta minus j sin theta. So cos pi by 2 is what? 0 minus j sin pi by 2 is what? 1. So I got minus j. So wherever I had W4 of 1, that is omega 4 of 1, I can write this as minus j, and W4 of 0 is what? 0. So I found the graph of it. Next thing is that I need to realize, I need to find what is x of 0 value, x of 1, x of 2 and x of 3. So how do I find? I need to take this as first input. What are the 2 values is coming for this one? This is the first line is coming, that is 0. Second is what? 2. So what is stage 1 analysis I can write? For first one, what I am doing? I am finding the stage 1 first input. I'll make the box. First see this one, then I'll erase this part and I'll explain you that box of it. So before erasing, see once again what actually the question. Question is, they gave 4 points, they asked to solve by using DIT algorithm. For doing this thing, what we have done? First thing we have taken, what is the meaning of bit reverse order? In that, there are 4 bits. That 4 bits, we took bit reverse order, we got this. To solve this problem, they asked in 2 conditions. One is DIT FFT algorithm, second one DIF FFT algorithm. For that, what we have done? For DIT FFT algorithm, this is your input side and this is your output one. So that input value we have mentioned. And we have combined two lines. This is the first stage 1 analysis of butterfly diagram of 4 point. This is called butterfly also. In that, we have taken next stage. In this also, this is your second stage. So this is 2 values we took. That answer is in stage 1. That one will be in stage 2. So this, now we found the value. Now what we have to do, we have to realize it at every point. What is the answer? Like if I'll see the first line, I had, what is the value here? 0. We need to add 0 plus 2. So 0 plus 2 will be 2. For the second, this point, what is the value? 0 is coming here and minus 1 of 2. So 0 minus 2 will be here, minus 2. That one I'll show you while writing it. I'll explain you here. Next is, we had here is 1. Next, what is the value is coming there? 3. So here is what? 1 plus 3. The answer is, for this point it is 4. Likewise, I can take for the last corner. This is the fourth sample value. In that, what I can take here is 1 is coming with minus and omega 8 of 4. It's 4. Omega 4 of 0. What is omega 4 of 0? We got 1 only. So no need of mentioning that. So it is 1 into this minus 3. So this is 1 minus 3. It is minus 2. So that one analysis we will do here. So now, what is the stage 1 values we got now? For stage 1, we'll make the box like this, right? We'll write the inputs also. This is what we are doing. We are analyzing this. What is the input first value? 0, then 2, then 1, then 3. So these are our input values. Clear? So we need to write the respective output. So how do we write the respective output? This is your output, you need to write. So tell me, what is the first answer for it? 0 plus 2. So I can write first answer is 0 plus 2, that is 2. Similarly, for the second one I can write 0 minus 1 of omega 4 of 0 into 2. So what I'll write? 0 here minus 2 omega 4 of 0. What is omega 4 of 0 we found just now in the previous condition? Omega 4 of 0 is 1. Then omega 4 of 1 is minus j. So this value we already found in the previous condition. So that value we are substituting here. So this is nothing but it's minus 2. This is 2. Similarly, next input or one input. This one. 1 plus 3. So I can write for this 1 plus 3, that is 4. Similarly, for the last one, what is the value here? 1 minus 1 of 3. So I can write 1 minus 3 into omega 4 power 0. Right? What is omega 4 power 0? It's nothing but omega 4 power 0 we had, it's 1. So 1 minus 3 into 1. So 3 ones are it's 3. So 3 minus this will be minus 2. Right? So we found all those values. So we'll write down that particular values here in the graph. So what is the first answer we do have? It's 2. Second one we do have is minus 2. Next we have 4. Next we have minus 2. So stage 1 analysis is done. Next we have to write the output stage. What is the output stage I do have? For this particular line, I am getting from this one. Because input, right? Same line is coming. That means 2. Right? Into, what is the answer for it? 4. So what I can write? 2 plus 4. So for the first answer, what is that? It's 2 plus 4. That is 6. So there is no minus, nothing. Only 4 is here. That line is coming this end and 2 is coming from that end. So this is become 2 plus 4. That's what it's become 6. Likewise here for this one, this is the line, right? So what is that one? Minus 2 into minus 2. So not into plus. Minus 2 plus of minus 2. So what I can write? Minus 2 plus of minus 2. That is minus 4. That one I got for the next stage. X of 0 I got, X of 1. For X of 2, since here you need to carefully do this. That is important. Here we are taking 2. That is 2 as it is. So first I'll write 2. Then here we do have minus. Right? So minus 1 of 4. So minus 4 omega 4 power 0. So 2 minus 4 omega 4 power 0 in that only as it is, because omega 4 power 0 is 1. So we will not change it. It will be as it is. Now x of 3. What is x of 3? Here minus 2. So first thing we'll write minus 2. then this minus 2 is coming and this also coming. What is that minus 2 after that? Minus 2, tell me what is this here? Minus 2 into this minus j, right? So minus 2 of minus. So this minus 2 and this will be what actually? Minus 2 minus 1 of minus j. So what I can write? It's nothing but minus 2, minus into minus plus, plus into minus minus, minus 2j. So what is the answers we got now? X of 0, x of 1, x of 2 and x of 3. So see once again, for x of 0, this line is coming, it's 2. And from here it is we had 4. So it is 2 plus 4, we got it as 6. For the second line, second graph of it, x of 1, it's minus 2 and here minus 2. So for that we will write only this particular value, minus 2 and minus 2. We wrote it. For next thing, x of 2, it is 2 with minus 4. So we mentioned 2 with minus 4. For x of 3, we had minus 2. Minus 2 is also there. This omega also we have to write for this particular value because it's coming for this line also. It here, not here. It's like this here. So omega 4 of 1, that is nothing but minus j. So after that, complete sequence you need to write down. What are the sequence? What is the output of the sequence? That you need to mention. So in that also, for x of 1, this is coming, right? Minus j. So here also we have to write minus j. Where is that x of 1 here? So minus j. So it's become now minus 2 plus 2j. Because j is there now here. For x of 1, j is there. That I have missed there. I am mentioning here. Clear? So for x of 1, minus 2 is coming and here j is there and minus 2. So minus 2 minus plus 2j, here is minus 2. So that's the reason it become minus 2 plus 2j. So now tell me total sequence, output of the sequence. 6 minus 2 plus 2j, then minus 2 minus 2 minus 2j. That is a complete sequence of your function by using DIT FFT algorithm for 4 points. Clear? So what we have done, input we have taken, stage 1 we have analyzed, we got those values. After getting the stage 1, we move to the stage 2. So after getting the stage 2, for taking this, whenever we had this corner values, that we need to mention. So we mention here omega 4 of 1, it is minus j, so that is nothing but j here. So omega 4 of 0 is 1, so we got the same function. So these are in normal order, x of 0, x of 1, x of 2 and x of 3. So we wrote that particular value for by using DIT FFT algorithm. Likewise, we will solve for the second bit. In that second bit, what is asked? They asked to find by using the DIF FFT algorithm for 4 points. Same sequence, x of n, what we had? It's nothing but 0, 1, 2, 3. For DIF FFT algorithm, what is the first step we need to write? We have to write the input is in normal order. The previously what we have done for DIT, it is in bit reverse order. What is the normal order? X of 0, x of 1, x of 2 and x of 3. So we wrote all those. We'll put first dots so that it will become easy for us to write the values. What is x of 0? It's 0. X of 1 it's 1. X of 2 is 2. X of 3 is 3. So we wrote next first stage 1. We are analyzing for stage 1 since it is 4 point. Only we'll write 4 points. So since we'll combine. Here what will combine in directly? Output will become, the previously it is what? Output. That output end will become now its input end. So here 2 crosses and this also 2 crosses we did. And what is the first for crosses? What we have done in the previous one? We put for feedback here. Now we'll put for the first one. W4 of 0, W4 of 1. This we have mentioned. That is what? Stage 1. So we done with stage 1. Next will be output stage, that is stage 2. Right? For output what we'll do? We'll put the dot same 1, 2, 3 and 4. So here directly we'll cross it like this. We will cross it like this. So now previously what we have done, we have combined 2, 2. Now here what I am doing, I am combining 4, directly initial 1 and then 1. It's like a reverse operation for DIF FFT algorithm. So what we have done, whatever the values we had, we have written like this. Now we have to go for analyzing this function. So before analyzing, what we should know? We should know that W4 of 0 is what? 1. Next is W4 of 1, we can write it as minus j. So just now we found these values by taking the twiddle factor. So now we'll analyze. So we need to write what is our output should be in bit reverse order. What is bit reverse order? X of 0, x of 2, x of 1, x of 3. these values we need to find out by the graph. So in this also again, whenever we had feedback, that should be -1, this also be -1. Likewise this input end, so whenever we are taking the values for it, this is what -1, this is also -1, we need to mention. So here is what -1, here is also -1. Now first stage 1 means we need to write this inputs value. What are those inputs? For that what I'll take, I'll make the previously what we have done, we are analyzing, right, like a box we'll prepare. It will be easy to simplify that one. So we are preparing the box. First what we'll write inputs. Inputs are 0, 1, 2, 3. Then we'll write stage 1. Stage 1 value, then we'll go for stage 2. What is stage 2? Is nothing but output stage. So tell me what is the first value we had. It's coming from here, it is 0. So here 0 plus 2. So I can write what is the value for it, 0 plus 2, that is nothing but 2. I got the first answer for it, it is nothing but 2. Similarly for the second one, tell me what is the value here. It is nothing but 1 and it's coming here is 3. So I can write 1 plus 3. So 1 plus 3 I can get it as 4. So what I did, I found the first value and I'm going to find the second value. So I found this is 0 here, this is 2 here. So 0 plus 2 is, I got it as 2. Similarly for this point, what is this answer for that particular graph, flow graph of it, 1. Here it is coming 3. So 1 plus 3, make it as 4. Likewise I can find for the next 2. What is 2 value? For this end it's coming from here. So 0 minus of 2. So I can write 0 minus 2, that is nothing but -2. Clear? For writing this one, what I can write, it's coming from omega 1. What is this omega 1 value? First thing is that it's 1 of j, because j is coming, right? So that one and this one we need to subtract it, write it as j. In terms of j we need to write. So how do we write that thing? So tell me, it's coming 1, here is 3 is there. So what I'll write for it, I'll write like this. So 1, it's coming from that end. Similarly here 1 is there. So 1, what is there with 1? W4 of 1 is there, that I have written. Here also there, W4 of 0, but it's 1, that's the reason we are not mentioning. So here W4 of 1 and 3 is also there, that is nothing but -3. So what we got, 1 minus 3, what I can write for it? I can write what? 1 minus 3, tell me. It's nothing but -2. What is this W4 of j? It's minus j. So I can write -2 minus plus 2j. So tell me the answers. This is 4, this is -2, this is 2j. We found. After that, now go for this total first analysis, x of 0. So x of 0 is what? This 2 plus 4. So 2 plus 4, it is nothing but 6. We wrote it. Next, x of 2. What is x of 2? 2 minus 4. So x of 2 is 2 minus 4. It is nothing but -2. Similarly, x of 1. Where is x of 1 is coming? It's coming from, x of 1 is -2, -2. Again, you are adding this one, -2 plus 2j, right? -2 from this end and -2j is from this end. Similarly for this end, tell me, what is this x of 3? X of 3 is equals to, what is x of 3? -2, this minus and this, it is what? -2j. So we wrote the output, but it is not in particular sequence, right? We need to write total answer. So therefore x of k is equals to, so we converted. So first answer should be x of 0, x of 1, x of 2 and x of 3. We'll write in order only, right? So tell me what is x of 0 answer? It's 6. Now tell me what is x of 1? -2 plus 2j. X of 2, it's -2. X of 3, -2 minus 2j. So that is a complete x of k by using DIF FFT algorithm. So by using DIF FFT algorithm, what we have found? From the graph, we first analyze all the stages. It is in not order, 0, 2, 1, 3. But output is in that way, we'll not write. We'll write position of x of 0, x of 1, x of 2, x of 3. So x of 0 is 6. X of 1 we had -2 plus 2j. Then x of 2 is this one. then x of 3 we wrote it. So likewise, we can solve the question related to DIT FFT and DIF FFT. As you can see in the previous one, we got the answer like 6 minus 2 plus 2j minus 2 minus 2 plus 2j. Slightly the difference of the position only. So here, so what is the conclusion of this one? When they ask the question based upon your DIT FFT algorithm, first we will combine 2, 2. So this will become the first stage, this part. This will be at the input side and this will be at the output side. When they ask DIT FFT algorithm, when they ask DIF FFT algorithm for 4 point, we will combine first 2, 2. We will combine, after that single will combine. And in the feedback, whenever we do have a feedback, this feedback line, that should be multiplied by -1 and -1. So how do we write the two values? This is very important to write the values. So what is this value? We wrote it here. This whole with W4 of 0. So for writing this, whenever we have this W, we'll take the value 0 and this 2. 0 minus 2 of this whole. This 2 of that particular whole. For this one, to get this particular value, 1 minus 1 of this whole. So 1 and 3. This is 3, right? So 1 minus 3 of the whole will be J we got. We wrote it, that one. So likewise, the question may ask to solve the questions based upon DIT FFT algorithm and DIF FFT algorithm. In the next class, since it is 4 points, right? So we'll do more problems on 8 points. They'll ask 10 marks, sure, definitely. Every year in digital signal processing, they'll definitely ask this kind of question for 10 marks. So practice these daily wise so that it will be easy for you to understand, and in depth this is just like a 4 points. They can be 8 points, they can be 16 points. So most probably they'll ask questions on 8 points. This, if they ask 4 points, they'll ask for 5 marks. So in that, first you have to draw the graph, analyze it and write the output. So this, instead of using the formula, we directly done the answer from the graph. So practice this question in the next video, in the next class of your digital signal processing. We will do 8 points DIT FFT and DIF FFT. Thank you.